Good afternoon to all. Welcome back to my channel. Now it's time to solve the SWAYAM NPTEL Advanced Computer Networks Week 9 Assignment 9, which last date is 26 March 2005. Now guys, let's start the questions. You can see here this is Advanced Computer Network, and there are near about 10 questions, and we will try to attempt the 10 questions one by one. Let's start the first question here. The first question is asking about which of the following is not a typical component of a data center network? Not a typical component of data center network, that is workstation. Workstation is not a typical component of data center network. Okay. So here guys, you can see why we choose workstation is not a typical component, because a data center network, that is DCN, typically includes servers, network, and storage. Server means host applications and services. Network here is switches, router, and connectivity. And storage is for data persistence. Okay. So workstations are end user devices, not a part of the core DCN infrastructure. They connect to the data center but are not component of it. That's why workstation option 1D is not a typical component of a data center network. Now, moving to the question number 2. What is the total number of servers supported by 4-port switches in a leaf spine technology? Total number of a server is 8. Okay. Total number of a server is 8. In a leaf spine topology with K port switches. Here K is equal to 4. Leaf switches connect to the services and spine switches. Spine switches connect to the leaf switches. So for K equal to 4, each leaf switches uses 2 ports for servers, and K by 2 and the 2 ports connect to the spine switches, that is K by 2. So here number of spine switches is equal to K by 2, that's equal to 2. Number of leaf switches is equal to K equal to 4. Servers per leaf equal to K by 2, that is equal to 2. So total number of server equal to total number of leaf switches into server per leaf, that is 4 into 2, that is equal to 8. Okay. Here the correct option is option B, that is called 8. Now moving to the question number 3. Which of the following statements is or are correct about fat tree topology? Fat tree topology. The fat tree topology correct option is fat trees has identical bandwidth at any bisections, and second is the fat tree built with K port identical switches supports, that is K square by 4 servers. Okay. So why we choose first option and third option? You can see the first tree has identical bandwidth at any bisections. That is a true statement. Fat tree topology ensure uniform bandwidth across any bisections, avoiding the bottleneck. Okay. Second one is a false statement because it contradicts the designing of a fat tree. Third one is a true statement because in a fat tree, the number of server is K by 2 square into K by 2 square, that is K square by 4. That is for K equal to 4, 4 square by 4, that is equal to 4 server. The last option D is a false statement because this overestimate the server count, and the correct formula is K square by 4. So we choose option A and option C. Now moving to the question number 4. Which of the following statement is or are correct about the modular data centers? Modular data centers. Modular data centers have high mobility, lower operational cost, faster development. A, C, and D. A, C, and D. Why we choose? Because you see high mobility. Modular data centers are portable and can be relocated easily. Okay. Next one is lower operational cost. Is it true? Because due to energy efficiency and scalability. Third one is faster deployment. It is a true because prefabricated modules enables rapid setup. The last one, that is option B, is a false statement because modular data centers are designed for efficiency, reducing cost. Because, but on the other hand, it is mentioning what? High cost, operational, high operational cost. So it is a false statement. Okay. Now moving to the question number 5. Which architecture is likely to require less cabling overall? Less cabling overall. That is called top of rack. That is TOR. Top of rack. That is TOR. Why we choose the option TOR? Top of rack architecture require less cabling because each switch is placed at the top of the rack, reducing the distance between the server and the switches. But in case of end of row and middle of row requires more cabling as the switches are placed at the end or middle of the row, increasing the distance to the servers. So the answer is top of the rack, that is TOR. Okay. Another, you can see top of rack. In top of rack architecture, a switch is placed in each server rack. Server within the rack connect to this switch with short cables. This is significantly reduce the length of cabling needed to connect the server to the network core, as most connections are connected within the rack. Okay, that's why we choose TOR is generally preferred as for cabling reductions. Shorter cable, reduce congestion and easier management. Clear? 5 option A TOR. Now, moving to the question number 6. Moving to the question number 6. What is the purpose of the spine switches in a fat tree topology? What is its purpose? Its basic purpose is to provide high-speed interconnection between ports. High-speed interconnection between the port, that is which is option 6, option C. 6 option C, to provide high-speed interconnection between the ports. In fact, a fat tree topology, that is spine switches connect leaf switches, which is form ports with servers, providing high-speed, non-blocking interconnection between the ports to ensure the scalability and uniform bandwidth. But in case of A, what is mentioned? To connect server to the network, it is incorrect because leaf switches connect servers. B is also incorrect because to provide a redundancy for the core switches, means spine switches are not just for redundancy. And option D as considered as the incorrect statement because what is mentioned? D option is to aggregate traffic from the A switches. It is also incorrect because aggregation is a secondary effect. The primary role is the interconnections. So here we choose the most appropriate option is to provide the high-speed interconnection between the ports. Then moving to the question number 7. Which of the following transport layer protocol is specifically designed to address the TCP incast problem? That is DCT-CP. 7 option A, DCT TCP incast occurs in data centers during main to WAN communication, causing throughput collapse due to buffer overflow. DCTT means data center TCP, transmission control protocol. It is designed to mitigate this by using ECN. ECN means explicit congestion notification to adjust the congestion windows proactively. Okay. Then what about the second option, DCQCN? DCQCN is for RDMA conjunction control, not for TCP incast. Option C is ROCE. ROCE is for RDMA over Ethernet, not for TCP. And last one is UIC. It's used for web performance, not for data center specific. So the correct option here is option A, that is DCTCP. Now moving to the question number 8. What is TCP incast? What is TCP incast? TCP incast, a network transport pathology affecting many to one communication patterns. 8 option D. 8 option D. TCP incast is a pathology in data center where many to one communications, that is multiple servers sending data to one receivers, causes buffer overflow, leading to the packet loss and throughput collapse. Here A, B and C we consider as incorrect statements because incast is a problem, not a protocol or encryptions. So correct option is option D. Now moving to the question number 9. How is the power uses effectiveness metric for power consumption in data center calculated? That is, the formula is total facility power divided by the IT equipment power. 9 option D. 9 option D. PU measures data center efficiency. So PU is total facility power by IT equipment power. That is, a lower PUE closer to 1 indicates better efficiency. But A we consider incorrect statements. Why? Because this is an inverse of DCIE. B and C also incorrect because not the correct formula. So the correct formula is what? Option D, total facility power divided by the IT equipment power. Clearly visible. Now last question. If a data center has a total facility power of 1,20,000 kilowatt and the IT equipment power is 90,000 kilowatt, what is the data center infrastructure efficiency in percentage? If you calculate, let's calculate, out of which what will be the percentage? See, DCIG is inverse of PUE, expressed at the percentage, that is DCIE, that is equal to previously IT equipment power by total facility power into 100. So given total facility is 1,20,000 kilowatt and IT equipment power is 90,000 kilowatt. That is 90,000 divided by 1,20,000 into 100. So 0.75 into 100, that is equal to 75%. Yes, 75%, which is 10 option A. Clear? Other options do not match the calculations. So what we calculate? 90,000 divided by 1,20,000 into 100. Simple calculation. It will be 75%. Clear? Now we are going to submit the answer of these questions. Guys, you can see. Thank you for taking the week 9. Assignment 9, your answer are successfully submitted. We attempt all the questions with explanations and it will be helpful your upcoming examinations. Okay. For assignment, it is okay. But in case this type of questions can come into your annual examinations or final examinations or theoretical examinations, you can, and the question may be somehow change, but the method is same. So guys, you are prepared, you must prepare very well for your examinations. If you have any doubt, any questions, you can put your question in my comment box. I will try to give the answer to your questions. If you like this video, you can subscribe my channel. You can share this video with your friends and colleagues so that the other people can get some informations. Okay, thank you for watching my video. Take care of yourself.